On to our next section, 7.2, so transformations of exponential functions. So actually we're going to go back to chapter 1 again. So how does each of the variables transform the graph? So if we look back at our original function notation, we had a, b, h, k. And with our exponential graph, we have the same thing, a, b, h, and k. Now all the rules still apply. Here, a was our vertical stretch. It's still our vertical stretch. B was our horizontal stretch, still horizontal stretch. It's still reciprocated when we actually say it. So for instance, if the B value is 3, it's actually a horizontal stretch of 1/3. We still have our H doing that horizontal translation. It's still the opposite of what's in the equation because we still have this minus sign in both of them. And finally, we have the vertical translation, which is our K value. Now this is going to be the most important one for us when we're doing exponential functions. So our first example looks very similar to examples in chapter 1 and 2. We have draw the graph. The graph of y equals 2 to the power of x is provided as convenience. State the domain, range, and equation of the asymptote. So we have y equals 3 times 2 to the power of x. Well, that's our a. So this is going to be a vertical stretch by a factor of 3. Meaning we're going to take each of our heights and multiply it by 3. So I'm going to go look at the heights that are nice and easy to find on here first. So for instance, 1. Well, 1 times 3 is 3. And then 2, so 2 times 3 is 6. And 4 times 3 is 12. Okay, well that's off. It's somewhere up here though. So we can kind of see the graph is growing quite quickly now. And then over here gets a little bit tougher. So I know this is 1/2 because this was 2. So that first one would have been 1/2. So we're going to just triple that. It's going to become 3 seconds or 3 halves. And then here we have our 1/4. Well, that's going to become 3/4. And we're getting smaller. We got 1/8. And it's getting harder and harder to kind of draw this graph. These are kind of meeting up closer and closer. The important thing is to not ever make it look like it hits that axis, the x-axis. So I'm just going to draw a little arrow showing it goes on forever. And try to make it match up there. And that's actually it as far as sketching it. Now we need to state the domain and range. So our domain actually doesn't change from these transformations. All x values are still going to be allowed. So we still have from negative infinity to positive infinity. And our range hasn't changed either. We still have this asymptote at y equals 0 where it never hits. So we have the curved bracket and it goes all the way to infinity. Finally, our asymptote. So that's going to occur at still y equals 0. All right, moving on to the next question. So we have y equals 2 to the power of x over 4. Well, that can be really is 1 over 4 times x. These mean the same thing. So that's going to be a b value then. So our b is equal to 1/4. But that means that we have a horizontal stretch of 4. So we're going to take all of these values and we're going to multiply them by 4, all of our x values, multiply them by 4. So here, well, 4 times 0 is 0, so that one's going to stay. And then here we have a 1, so 4 times 1 is 4. Still, the height stays the same. Now you can see we're already almost off the graph, so I'm going to go on to the other side then. And then here we have 1 times 4 again is 4, or negative 4. And again, we're going to be off the graph. So this is really stretching it a lot. So it's still important to make sure that it doesn't look like it ever hits this axis. Okay, moving on. Our domain hasn't changed at all from a horizontal stretch. So it's still negative infinity to infinity. Our range, we still have that asymptote at y equals 0. So we're still going to go from 0 to positive infinity. And we do have that asymptote as mentioned at y equals 0. Our next two examples are the same thing, with just now we're dealing with vertical translations and horizontal translations. So again, draw the graph. We have y equals 2 of x is provided as convenience. State the domain, range, and equation of the asymptote. All right, so this is our k value. So we're going to have a vertical translation of 3 up, meaning we're going to move all of our heights up 3. So I'll go start with easy heights. We have a height of 1 here. That's going to go up 3. We've got a height of 2 here. That's also going to go up 3. So 1, 2, 3. We've got a height of 4. It's going to go up 3. So 1, 2, 3. And this one's going to go a little bit off, so up 3 as well. Next, we'll move these ones a little bit tougher, so that's 1/2. So move up 3, 1, 2, 3. And then we've got our quarter moved up 3. And this kind of continues the same. Now again, it's very important to make sure it doesn't ever actually hit this line, because the asymptote has actually been shifted up 3 as well. So this is our new asymptote right here. And you are allowed to draw it in. And it's probably better if you want 100% on that diploma to draw it in. And we label that, that's y equals 3. Make it very explicit that you understand that that is an asymptote there. And then we're going to connect our lines. It is continuous. Again, make it look like it doesn't actually hit the asymptote. And so now we can state our domain and range. Now these have changed. Our domain is the same. We can still have any x value. So it's still negative infinity to infinity. But our range is a little bit different because that asymptote is moved up. Now it approaches 3. And it still goes to infinity on the other half of the graph. Our asymptote is obviously also changed then. And it's now at y equals 3. For our last example of this, we have y equals 2 to the power of x minus 1. Well, this time, now this is not a minus 1, it's actually a plus 1 there. So that means that we have a translation, a horizontal translation of 1 right. So we're going to take all of our points and just shift them 1 right. So this point's going to get shifted 1 right, 1 right, 1 right, 1 right. And then on our negative x's, so 1 right, and then 1 right. Again, it's very important to make sure we don't look like we're crossing that asymptote. The asymptote, you can see, has not moved this time. So it is actually the same. So the only thing that affects our domain and range at this point is our k value. So our domain is our regular domain then, so negative infinity to positive infinity, and our range is still from 0 as our asymptote all the way to positive infinity. And then we have an asymptote still at y equals 0. Let's take a look at some tougher examples. So we have the graph of y equals 1/2 to the power of x is provided as convenience. State the domain, range, and equation of the asymptote. So very similar question. What's different though is now we have multiple transformations happening. So we can see we've got a plus 3 here. Well, that's actually like a minus 3. So that's going to be a horizontal translation 3 right, or sorry, left. And then we have this minus 2. So that's going to be a vertical translation 2 down. Now that k value is really important because we know that our asymptote then is actually going to be shifted down 2. So I'm going to draw that in right now. So that's y equals negative 2, meaning my graph should never look like it's going to cross that. Now I have this graph already given to me, so I can take each point and just translate them 3 left and 2 down. So I'll start again a nice little point of 1, so 3 left, so 1, 2, 3, 2 down, 1, 2. And I'll go to my next point that looks a little nice is right here, so 2 down, so 1, 2, 3 left, 1, 2, 3. And then we've got again 2 down, 1, 2, and then 3 left, 1, 2, 3. That's going to be off the graph at this point. So let's look at our positive x values then. So this is 1/2, just based off of what our base is. So we're going to go again 3 left, so 1, 2, 3, and then 2 down. So 1, 2. And then at this point, we're going to follow the same pattern where it's going to get half smaller by half each time. Do not let it look like it's going to hit that asymptote. That's why I drew that in there already. So I'm going to stop at that point. I've made it very clear there's something here. There's an asymptote there. So now we need to finish this question. Domain. Well, that doesn't change. That's still negative infinity to positive infinity. Our range has changed. It's based off the asymptote. So it's now at negative 2 is what our graph approaches. And it goes all the way to infinity still. And then finally, that asymptote is at y equals negative 2.